Well, good morning, everyone. How are you today? Hopefully we've got an image. Hopefully we've got audio. If you have any questions for me, there's a chat window. Please go ahead and send your questions up to the chat window. My name is Jim Davis, and I'm the Regional Marketing Engineer here at Flip Networks. And today we're going to be talking about a question that's come up in a couple of Linkware Live and a couple of other events that we've participated in. We've seen that there have been some questions about how to do the testing of MPO links, and I wanted to touch on that in a little bit more detail. So today, briefly, it's a commercial presentation. We're going to talk about the Fluke Networks Versiv platform. Cleaning and inspection, which probably should be inspection and, if necessary, cleaning, but boy, our biggest impediment to fiber. Calculating a loss budget. There are established methods for testing our friends, the MPO cables, the MPO trunk cables, and the cassettes. But knowing what your loss budget is, knowing what is going to be a pass and a fail value is important for us. Now we're going to look at testing both the pure cables, and we're going to look at testing through cassettes. No, we're not going to look at polarity testing. Sorry, there's three, A, B, and C, pin up, pin down, and switching every other one. But it's not my purpose in this presentation to explain MPO connectors. I have a good feeling that you guys have seen those before. And I was going to ask if somebody could send me a note to let me know if they can hear me. I don't know that any audio is going out. I hope that it is. If someone could zip in the chat window and just send a note to me saying that they are hearing this, that would be most appreciated. All right. So no one is telling me that they can hear me. I might be doing this wrong. Going once, going twice. There we go. Thank you very much. I appreciate that. Sorry, everyone. Okay, so we're going to look at our loss testing. And one of the important things in doing the loss testing is setting an accurate reference. We're also going to talk about OM5 testing. There's our trusty green cable here. And we're going to end talking about results management. We do this testing. We create the test results. How do we test the right thing? How do we get paid more quickly? How do we send those test results out so that our customer gets them and we can get paid? All right. As always, we've got to touch on our Versiv platform. The Versiv platform, the same mainframe, the same screen. And what we can see from this, we have a fiber loss module. We have a copper module, the DSX 5000, that's good for all categories of cable up to 6A. We have an OTDR module, the OptiFiber Pro, that comes in both multi-mode and single mode versions. And a new member of the Versiv family, the DSX 8000, which will allow us to test Category 3, Category 5E, all the way up to the new Category 8 that's just recently been announced and approved as a standard. So, just a little tiny bit about the MPO connectors. That's a multi-fiber push-on connector, also known as the MTP connector. The MTP is the high-performance version of the MPO connector, but essentially they're all about the same shape. Most common flavors that we're going to see in our data center and campus environment are going to be these 12 fiber connectors. You see they've got one row of 12 fibers there. Now, those are also available in 8 and 10 fibers because 40 gig only uses 8 fibers. There is a version where the 4 fibers in the middle are not used, but the 8, 10, and 12 fibers are exactly the same form factor. There's a 16 fiber, and then we start going up. There can be some really high density versions. You see, we start adding multiple rows. I've got a picture here of the 24 fiber version, but there's a 36, a 48. We go something up at like a crazy 72 fiber as well. Now, one other thing that I want you to notice in these pictures, we can see that they're pinned and unpinned versions of these connectors. There's the pinned version, and here's the unpinned version. In order for these to properly mate, of course, we need a pinned to an unpinned connector. And pin-to-pin does not work, and unpinned to unpinned also is not going to work. You're not going to get a good alignment with the connectors. That may be a source of your problems. The idea of the MPO connector is that in the future, we're going to be able to accelerate. One thing, let's talk about it now. Today, at a single wavelength on a single fiber, we can transmit 10 gigabits. There's talk in the future of being able to go to 25 gigabits, but today let's stick with that one wavelength, one fiber, we get 10 gigabits. Now, if we had multiple wavelengths available on the fiber, we could transmit at 10 gigabits each one of those wavelengths. It's one of the tricks of single mode fiber. Really, we don't know how many wavelengths are available to us yet, and every time we get a new one, we can put another 10 gigabits on it. And the other option for accelerating our speed is to transmit in parallel multiple 10 gigabit links. So down the road, we expect that though you may be using 10 gigabit today in your backbone in your data center, tomorrow you may upgrade to a 40 gigabit switch that will have an MPO port like this and will transmit 10 gigabits on each of 4 fibers. But in the event you're not using 40 gigabits today, well, how are you going to connect? What we do is we put these cassettes on either end. And inside the cassette, you can see on one end is our MPO connector, and there's a short, maybe about 50 centimeters, couple feet of fiber, 900 micron buffered fiber that's terminating here in an LC connector. So I can have multiple LC connections. And yes, these cassettes are also going to be to the A, B, and C, different wiring standards. Here we go. Now, as always, before I say cleaning and inspection, but better if it said inspection and cleaning. You don't always have to clean. Take a look at the connector. What's the condition? If it's clean, please don't rub a cleaning stick over it. Don't generate that static charge to attract some dust. But please do inspect your connectors. Now, I've heard stories where they're going to be MPO cassettes that come hermetically sealed from the factory. They may have a white piece of plastic over the MPO port. Those are designed to be clean, and you really want to keep them that way. But other than that, feel free to inspect any MPO ports, especially MPO trunk cables, and especially LC and SC patch cords. I don't care if you just opened the bag and it just came from the factory. That dust cap, there's a reason it's called a dust cap. That's where the dust is stored. Maybe they could be called a port protector. But anyways, you really want to inspect your connectors before you plug them in, because if you connect a dirty connector, it's going to transfer that contamination. Now, what we're seeing here is a camera, and here's a tip that we can put on the end of the camera so we can get this great image. This is the background, the composite material in the connector, and here we're seeing 2 fibers. These look like 50 micron multimode fibers. This one has some type of oily contaminant here around the core of the fiber. Here's a piece of dust that we have. And I got a good one yesterday. Look at that. I can't even see any of the core. That is just not going to transmit very well. The fiber just to the left of it, actually the core is still clear for the moment, but certainly I don't want to leave that piece of contaminant there. Possibly I'll break the fiber, which will be no fun. One other quick note, some simple practical stuff. When you're using these fiber cleaners, there's some different types of them. This actually is an older version of ours that has a wheel that turns. There's a new version that's a push-on. You have this clear plastic tip on the end, and boy, for all the world, it looks like you want to take that tip off to use it. But no, that tip actually lifts up, and you can slide the MPO connector in there to make sure you get a good mating, get a good clean on it. Now, when we're working, there are 2 types of connectors that we're going to get, UPC and APC. UPC, you can think of that it's kind of squared off, sort of a 90-degree flat surface. But when we're working in single mode, we're going to be really worried about reflectance. And in order for us to avoid the reflectance, they have what we call an angled polished connector. There's a slight angle put on the connector. And what happens is reflections that in the UPC will get sent back down the fiber. In the APC, we're trying to direct those reflections to go out through the cladding of the fiber so they don't, I'll say, contaminate our communication. Remember, our communication is we have light, it's on, it's a 1. We don't have light, it's an off, it's a 0. Now, what we're going to find is as we speed up our communications, that reflectance value starts to get really important because our bit time gets shortened. And if there's a reflection, in a zero or a spot where there's no light and our switch or our server interprets that as light, we may get an FCS or a CRC error, which is going to slow our network down. But the important point here is we need two types of inspection tips. Here we have the UPC tip that we'll be using with Multimode, and here you can see there's a slight angle on the end of this tip. This is the APC or angled polish connector. Now, some of these tips for the cameras will have one wheel, some of them have two wheels. The one wheel is, I always forget if it's X, Y, but we'll call it left-right movement. And then there'll be another wheel that we can use for up and down movement. This up and down is especially important if you're using a 24, a 36, or 48 fiber connector. So you need to go up and inspect the other rows that are going by. So we have our connectors clean. We're ready to run our test. We need to calculate what is going to be a pass and a fail value. Fiber is a little bit more complicated than copper. In copper, we test to 5E, we test to 6A. Why do we test to 5E? Because 5E defines a pipe that's larger than the requirements for the application. A 5E pipe is big enough to fit 10 megabits, 100 megabits, gigabit fits in there. And knowing the size of that pipe, they even have put 2.5 and 5 gig inside that pipe. However, in the case of fiber, there's a conflict. Things that work for the TI 568 standard don't work for the application standard. I'll give you a real simple example here. The ANSI TI 568.3-D gives us 2 kilometers of permitted distance, but 10 gig Ethernet isn't going to go over 300 meters. So in an ideal world, we're going to use a custom limit that takes into account components of the cabling standard. The more cable, the more connectors, the more splices we have, the more attenuation we should expect, but limited on the high end by these fixed application standards. Let's take a limit at where this can complicate our life. So here we have a cassette, an MPO cable, and a cassette. And we have a customer who wants to run 10 gig on this. Now, here we see the Certifiber, the OLTS, the optical loss test set, the configuration page. It's set up to do a smart remote. We're going to get light from the far direction. And we're testing OM3 fiber. And we've got it set to the TIA, the 568 multimode limits. However, we've selected a connector type LC. And looking at this, the person has counted 1, 2, 3, 4 connections. Now, if we work with those 4 connections, let's take a look at what's going to happen to us. Standard gives us 0.75 dB of loss when we have 2 standard grade connections mated. So we got one connector there, another one here, another one here, and finally this LC connector on the far side, plus a distance of fiber. Now we know 10 gig can go 300 meters, so let's put 300 meters of fiber here. 3 dB per kilometer, that's going to give us almost a dB of loss. Add all that together. I know, math, sorry, you guys don't have to do it. We got it automatic calculate. We have it calculated for us ahead of time. 3.9 dB of loss is permitted per the TIA standard using these 4 connections. However, we know that the 10 gig limit is only 2.55 dB, so this design, while it would be acceptable for TIA, is not going to support 10 gigabit under these conditions. So what we need to do is instead configure our tester and tell it, look, we don't have 1 and 2 connections. When we're looking at an MPO cassette, we have a loss value for the entire cassette. In the case of TIA, we have 2 cassettes here. We've selected the MPO module connector type, and the TIA gives us 0.75 dB of loss for the whole cassette. Now, what you'll find with the manufacturers today is they're going to have at least 2 and maybe more qualities or performance level for their cassettes. They're going to have a standard grade cassette that may have 0.75 or maybe even 0.5 dB of loss for the whole thing, and they'll have an enhanced or a high performance grade cassette that may have as little as 0.3 dB of loss for the combination of both connections. Now, this is very important because we just saw that even in this case, we've got 0.75 in our 300 meters, gives us 2.4 dB of loss. We're getting to be right there for 10 gig. And if we had 2 sections of cable. Obviously, it couldn't be 300 meters between each one, but if we've got two, say, 100-meter trunk cables and we've got 4 couplers there, got to be careful about what our loss value is. I don't want you to be tricked by looking at the fluke tester and having the fluke tester giving you the green pass, but comparing to a TI limit that won't support the application you're using. So please be careful and understand what the application limits are that you're going to be working with. Well, that's all well and good, Jim, but what are the application limits? Oh, funny you should ask. So there's a standard. Within the standard, especially the application standards, the IEEE standards, we can look up and see for the different applications what the loss value is on 62.5, OM2, OM3, OM4. Probably start seeing charts with OM5 now that that's been approved. And we're going to see what the attenuation value is and what the distance value is. So again, you may end up using custom limits. Okay, so we've picked our loss value, we've configured our tester, and now we need to test. We have 2 options for how we can test. Many of you have a light source and a power meter, and if we're just going to test this trunk cable, the MPO to MPO cable, we're going to test it with a light source and a power meter. This gets to be a little tedious because we've got 12 fibers we need to test, and many manufacturers today are offering testers that have an MPO port. You can plug an MPO port directly into the tester. Obviously, this is going to be a lot quicker for testing those 12 fibers. Let's take a minute to drill in a little bit to our I almost want to call it a family of testers that we call the Multifiber Pro. Now, the Multifiber Pro is made up of a meter. Let's see. Source, here's our meter, a source and 3 sources. Our meter works both for single mode and multi-mode. It's going to work at 850, 1310, and 1550, and it's actually 12 power meters put in there. Now we're going to need a source. When we're doing multi-mode, we have an 850 source. It's actually 12 sources. And in the case, and it is encircled flux compliant, the multi-mode unit for what it's worth. Now for the single mode, we have both 1550 and 1310. Now, these have 12 sources and 12 power meters, so it can be a little bit more expensive, but what it does is it saves us time. If you have a data center worth of MPO trunk cables to test, you've got a container load of trunk cables that need to be tested, project manager on the data center isn't saying, oh, take your time, do it as cheaply as possible, all the time in the world. No, they're screaming, come on, we're late, the racks arrived late, the fiber arrived late, the carpeting arrived late, we've got to make up time, we've got to get this done quickly. Getting it done quickly doesn't mean bypassing steps like verifying that the cables weren't broken in shipment, and having a multi-fiber allows you to quickly verify the loss and the polarity of your MPO trunk cables before you install them. Now we can save the test results with that and send it up to Linkware to store them. Let's take a look at how we would run a test. So here we have our light source and our power meter. First, we're going to check our first cord, make sure that we have good loss values on that. We're going to disconnect that, and we're going to plug in our second MPO test cord. We can sort through, pushing these buttons, we can sort through each one of the fibers individually. Another day we'll talk about these ovals, but in the case of power, each one of the ovals is showing the relative power compared to each one of the different ports. So once we see a good consistent power level, the units have warmed up, we're going to set a reference. Now, when we set a reference, we want it to hold showing just a single one of these ovals, because now the ovals are going to represent a loss value relative to the limit that we've put in the tester. And we can put in a specific limit for each one of these cables. Now we're going to try and get that to hold on 0 dB. If it is holding on 0 dB across all 12 fibers, the sources are stable, we're ready to start our testing. Now, the process of how we do the testing is going to be very important for us to make sure that we're doing the test accurately. And the first thing that we want to do is make sure that when we disconnect it from the power meter and not the light source. In the light source, there's a physical contact. The alignment may be bad, but the alignment is what it is. And if we disconnect it and reconnect it, we'll change the alignment, we'll introduce new uncertainty. Now we're going to plug in that cord we checked in the first screen to make sure it's good. Notice that both of these cords are pinned, so we can't join them together. We're missing the step about the verification of the known good leg, which we tested beforehand. Now we're ready to test our unpinned trunk cable. We connect to it and run that test. Now, a couple of things that are real nice about the multifiber. One, we get all 12 fibers on a single test report instead of getting 12 test reports. And also it's going to show us the polarity here. Polarity is real helpful. I think it's an A polarity. I think it's a B polarity. Let's verify that. And it's not that I don't trust the houses that are building the patch cords, but every once in a while, they've got to get a fiber mixed up. And I'd rather find that out before I install the fiber than afterwards. Now, we can also use this in other situations, and one of the more common applications I'm hearing about from the field is people using MPO cables to test or to run 40 gig from one switch to 4 different servers connected at 10 gig. We may have a 40 gig MPO port on our active equipment on our switch, but we have just LC connectors on each one of our 4 servers that are being served. So how do we test that? We can do this same thing, verifying with our MPO cord, get our stable reference. Now on the far side, what we're going to connect is a fan-out cable. And we can plug that fan-out cable into the LC ports, and this way we can test 8, 10, or 12 fibers all at once. Here's an example we're seeing of just an 8-fiber cable. Curiously, news to me, hopefully, perhaps you guys know this already, you know now. When we have an 8-fiber cable, it's the 4 fibers in the middle that are dropped out. So here we see a gap on these 4 middle fibers, but it's fine. Multifiber Pro will detect this automatically. There actually isn't any setup required to tell it I'm getting 8 fibers. Now, on the other side, we also see cases where somebody may have 16 or especially 24. They've got 2 rows of 12. They want to do 100 gig full duplex, 10 fibers, 10 megabits per fiber, 100 gig transmitting, 100 gig receiving. If they want to do 100 gig full duplex, they may be using a 24 fiber MPO. And the way that we would test a 24 fiber MPO with the multifiber is to have a breakout cable that goes from 24 fiber on one end down to 212s. Briefly, I want to talk about how we would test the MPO trunk cable, because there's some really important steps that you need to follow here to make sure you get an accurate test. And when are you going to do this? I have 1 MPO trunk cable I want to check. I have 2. If you have 1 or 2 MPO trunk cables, as much as I'd like you to have a multifiber, it's going to be tough to justify the cost of the multifiber for just a handful of MPO trunk cables. When you have a lot of cable, the time saving of the Multifiber Pro is going to make it worthwhile. Let's take a look at how we would test a single one. So we're going to set our 1 jumper reference as we always do. Make sure we've got a good reference value. Disconnect from the power meter, of course, because we're not making physical contact. We want to maintain the alignment on the output here. Connect our known good leg and check to make sure that our known good leg has less than, in multimode, 0.15 dB of loss, 0.25 dB of loss for single mode. That 0.05 dB is for field conditions. Now here's the tricky part. We're going to set a reference again at this point. Here's our 2 jumper reference. So we've set a reference to 0. Now we'll disconnect at the coupler, and we're going to put in a short, call it a foot long, field calibration cord. And we're going to check to make sure that the loss value of this new coupler that we've introduced doesn't exceed what we're looking for. So we'll run a test, and we'll check again to make sure multimode we've got less than 0.15, single mode less than 0.25 dB. Remember, we already included this first coupler in our reference, so it shouldn't be there. So now we're checking the quality of the connection on this second adapter to make sure it doesn't have too much. And from here, we can set a reference again. Now this reference includes the loss value for our 2 couplers. We're going to remove our field calibration cord, and now we can install a fan-out cable on each end and our trunk cable to be tested, and we're going to go 2 at a time through the whole cable. A little bit more complicated. You want to make sure you're doing the right steps to set the reference. That will give you a much more accurate test. So what about if you have MPO cable? What about if you have cassettes on both ends? Well, if you have cassettes on both ends, it's going to be just a standard loss test. But let's take a moment to talk about what a standard loss test is, because following some basic steps is going to help us to minimize or reduce the uncertainty that's introduced and make sure that our results are repeatable. When we run a test, we're going to run a test. Our customer may run a test. A consultant may run a test. Maybe the manufacturer will come along and run a test afterwards. We want to make sure that the test results that we have are in line with the test results that the others have. And the way that we can be assured that we have the same test results, even among testers made by different manufacturers, is 4 key steps. We want to make sure we're using an LED source. Sometimes I get a question where people say, well, I'm going to be transmitting with a VCSEL. Shouldn't I use a VCSEL source? No, a VCSEL doesn't transmit a wide enough, it's not physically wide enough beam to fill the entire fiber. So if we use a VCSEL source, it has a tendency to give us an optimistic rating. And there are 26 different types of VCSELs. You don't know exactly which one your active equipment is going to be using. We want to use reference grade connectors, and we want to make sure that our test cords, our test reference cords, comply with the encircled flux requirements. And then, of course, we want to set a one jumper reference. I can't emphasize enough how important it is to set a one jumper reference. Where we get in trouble with the one jumper reference is we have an SC connector on our test equipment, and we have an LC connector on the wall, and we go, well, I'm just going to use a hybrid cord so that I can connect from SC to LC. Please don't. Please make sure that your equipment, that the input port is adjustable so you can have either an SC or an LC or FC or ST or, well, we're not going to have every flavor. Probably you're not going to be testing SMAs, but you want to make sure that you can have an input port that supports the most common fiber connector types. So setting our one jumper reference, we're looking at multimode here, and this is our encircled flux mandrel on our test reference cords. We're going directly into the far end. This is going to be the most accurate reference that we can set. Check and make sure that we've got a good value on the reference, and then we're going to go and just like we did on the example of the test reference cord, just like we did on the example of the MPO trunk cable, we're going to verify our known good leg and make sure it really is good. So we'll connect the known good leg, and we will connect the main and the remote together, and we're going to run a test. And we want to make sure that we're using reference grade connectors. A mated multimode reference grade connector should have a 0.1 dB loss value. We're going to give you 0.05 dB, and in single mode, that's 0.2 loss value. Remember, the standard gives us 0.75, so this 0.1 dB says that these test reference cords, especially this connector, is a particularly high quality connector. It has a very tight tolerance. We make sure that the fiber is exactly in the center. We make sure that the polish on it is particularly good. There's good geometry on the polish. And also we want to make sure we have tighter tolerances for the actual fiber to make sure that the fiber is rounder, less likely to be oblong. One of the things that's neat about testing this known good leg, a simple rule for you guys when you're in the field, another question I get a lot is, how often should I be resetting my reference? Well, you have to set a reference every 24 hours with the Certifiber platform. And we used to suggest that every time you turn the tester off, you should reset the reference. It gets to be a little tedious. You go to lunch, you come back from lunch, the tester powered down. Do I really have to set a reference? Well, as long as you haven't removed the cord from the output port, you haven't changed the alignment on the output port here, turn the testers on. Let them warm up. We want to get them to room temperature, maybe 15 minutes, depends on where they've come from. You're in the far north and you're coming out of 20 below zero, they've been in your car 40 below zero, it's going to take them a little bit longer to warm up. But you're coming back from lunch. They're still at room temperature. Give them about 15 minutes to warm up. Now, you can just plug in your known good cords and run this test. If you get a loss value between 0 and 0.15, your reference value is still good. And hey, save that. Save that test reference cord verification. If down the road the consultant or the manufacturer or the end user is also running a test and they get different values from you, let's walk through it. What was your reference value? What was the loss value of your known good cord? If it's well documented, you can defend the work that you've done. Now, let's talk a little bit more about encircled flux. We're looking at the connectors here from the end. And what encircled flux is trying to do is make sure we've got the core and the cladding here. We want to make sure that the core of the fiber is properly filled. An LED is going to overfill the core of the fiber. We're going to get some light in the cladding, and that light will go a short distance. So if we don't have encircled flux compliant cords, our reference is going to be too hot. If our reference is too hot, that's going to mean that we're going to have too much loss in our measurement. If it's underfilled, for example, if we're using a VCSEL, we're going to give ourselves an optimistic result. So the idea of encircled flux is that we have an ideal filling of the core, not overfilled, not underfilled. Let's take a look at this from the side. An encircled flux compliant cord, notice we've got a misalignment here between our two connectors. An encircled flux is just the right amount of light, and it's going to pass good links and fail bad links. Now, if the fiber is overfilled, as we see in this example, we're going to measure some excessive loss, and you may actually fail good links given that your reference was set too hot. Underfilled loss, you're going to get optimistic values. Hey, look, it passes. It passed everything. That's great, until your user comes along and tries to plug in his new 40 gig switch, and it doesn't work. And they call up the switch manufacturer, and they say it's not working. And we all know what the switch manufacturer is going to say. It's the cabling. Then it falls on us to make sure it's not the cabling. Moving right along. Talked about the importance of the test reference cords and the connectors. The standard recommends the use of reference grade connectors. Now, we just mentioned that a mated pair of reference grade connectors is going to have 0.1 dB of loss. Single mode will be 0.2. Now, if we connect a 0.1 dB loss reference grade connector to a standard grade connector, we're not going to get 0.75 dB of loss. We should only get 0.3 or less loss when we made a standard grade connector to a reference grade connector. Now, the standard address recognized this, and they've given us new values for the mated connection between a reference grade and a standard grade connector. For reference to standard grade, we don't want to budget for 0.75 dB. That's not accurate. You're cheating yourself to use that value. The standard is saying that we should now use 0.3 dB. Yeah, that's pretty tight. And in single mode, where the mated value of two reference grade connectors is 0.2, if we have a reference grade to a standard grade connector, the standard asks us to budget 0.5 dB for this. Let's take a look at this in a multi-mode example. Again, this is the ANSI TI 568.3-D. The new loss budget values for your reference grade to standard grade connection is 0.3 dB. And we send a reference grade connector, an encircled flux compliant reference grade connector. So we're looking for 0.3 dB here. And on the far end, where we have the reference grade connection to a standard grade connection, we're going to be looking at a value of 0.3 dB. Other connections that we may have along the link, we're going to continue to value those at 0.75 dB. So in this example, where we appear to be connecting to perhaps two MPO trunk cables mated through cassettes and a patch cord, we have 0.3, 0.3 plus 0.75, 0.75, and the number of meters or kilometers of fiber times 3 dB per kilometer. That'll give us our overall loss budget. So let's take a look at our power meter now, because a lot of times I get a question, how is this going to measure? UPC, we know how it's going to measure the loss, but will it work for APC connections? Now, APC connections, typically they're going to be green. In the case of MPO trunk cables, it's not necessarily going to have a green connector on it, because a single mode MPO trunk cable is just expected to be an APC connection. Typically on SC or LC connectors, the green ones, there's a slight angle, a 7-degree angle on the end face here. And we can test those both with the multifiber and the certifiber. Here's the certifiber with our power meter with our APC connector getting plugged in there. How do we do this? Well, we work with something called a large area non-contact detector. We're not physically touching. Here's the end face of the connector, and it's not physically touching the detector. There's a small air gap there, and there's a small angle to the detector to make sure that we're not reflecting light back into the fiber. And this also helps us because it reduces the possibility of damage to the end face. Remember, whenever you're going to plug a cord into the output port of your light source, make sure you inspect that cord, because we know Murphy's rules. If there's a grain of sand in there, I know that's an exaggeration, but we plug that cord in, one of those things is going to break, and it's either going to be the cord or it's going to be the output port on our light source. And Murphy says the more expensive of the two is going to break. Now, we have this both in our Certifiber Pro and in the Multifiber Pro. So what we're going to do here, we have this gap, our large core detector, and here we're looking at a UPC connector. You see the square corners and the flat surface. Here's our multimode fiber coming in and our air gap. So it's a non-contact surface. That's why we can disconnect from the power meter and plug it back in. Now, here's how we're going to be able to measure UPC connectors. Now in APC connectors, we see this angled contact surface, so it'll plug in there. Same way, we're still not touching, and our large core fiber can receive all the light that's coming out of the fiber that's plugged in. So, nice trick there. Well, thanks for explaining this about the MPO cables, but I've also started to hear about this new OM5 fiber, the OM5, the wideband multimode fiber. How do I test OM5 fiber? What steps do I need to take? Do I need to get a new power meter? Well, good news and bad news. The good news, the process is the same as OM3 and OM4. We're going to test it with the same light source and the same power meter. We're going to test at 850 and 1300. The wideband multimode fiber, so-called OM5, what it's going to allow us to do is, here we see this graph that's showing us an attenuation value versus the wavelength. And what this is showing is there is a linear connection between the loss value at 850 and the loss value at 1300. So the good news is I don't need a 953 light source to measure what the loss is going to be. I said there was a bad side to this. There is. There's a terrible side. I make those light sources and power meters. So if you don't need one, what are we going to sell? Anyways, we're going to work on process here. And if we're testing at 850 and we're testing at 1310, given that the loss value is linear, we don't have to test at 880, 910, and 950 to know that our loss value is acceptable on the OM5 fibers. So, moving right along, one of the other useful points about when we're running these tests, either on the MPO trunk cables or through the cassettes, is, well, the manuals. I know that we all hate to read the manual, but I did want to take a moment here to comment about the knowledge base that we have on our webpage. If we go into the support tab, within the support tab, we'll get to the knowledge base. And if we select the Multifiber Pro and search, we'll get a list of all the articles related to the Multifiber Pro. One of the most common questions that we come across is, I have an unpinned trunk cable. I have a pinned trunk cable. I have a pinned patch cord. I have an unpinned patch cord. My MPO cassette is pinned, and I'm plugging it into an unpinned link. How do I configure that? How do I set the reference? And all of these articles are explained within the knowledge base to help you get through how you're going to be setting up these different configurations. One other useful part of the knowledge base is field test specifications. It can be complicated to say, yeah, just follow the TI 568. Yeah, I want testing per TI 568. Remember, we've talked about the conflict between TI standards and application standards. You really want to add some more verbiage there to make sure that they're being tested properly and you're going to get test results that meet your requirements. Within the knowledge base, we do have a field test specification. There's one for fiber. There's also one for copper that helps you, let me call it the weasel words that we can apply so that when you request the field certification will be done the right way. All right, so we're going to request our testing the right way. We're going to explain the right way to set the reference. Now, I need to get those test results. Hopefully you guys have heard of Linkware Live, and hopefully Linkware Live is something that you're using today with your Versiv testers. I wanted to talk for a minute about Linkware Live. I've been surprised as I go out in the field and talk to more and more customers. I'm finding more and more people who are using Linkware Live, and it's actually overcoming some of the concerns that the marketing department had brought up. It always feels funny when I'm talking about things the marketing department has given me for the first time. So I go, is this a real thing, or are you just making that up? Do people really use their test results, lose their test results? Do people really have test results in a tester that they don't download? I'm talking to people. Turns out they really do. Now, what I wanted to walk through quickly in Linkware Live is a little bit of the process. Now, what is Linkware Live? We're all familiar with what's now called Linkware PC, the software that manages the test results from the different testers from our old DTX and our new Versiv units. But Linkware Live is now a Linkware version that's in the cloud, and it starts to be part of a full process. It's not just, you can use it as a USB stick in the cloud, great. You could also use Google Documents or Dropbox. Go ahead, that's fine. Your test results will be more accessible. But there's a whole process to using Linkware Live. I wanted to walk you through here real quickly. The first thing that happens is the project manager, the person who has the bid specification, the person who has all the cable IDs. They can configure the test that needs to be run in the cloud from wherever they are. They don't have to have the tester in their hands. Now, configuring a test on the tester it's pretty straightforward. It's pretty simple, especially if we're talking about a Cat 5 or a Cat 6 test. Not a lot of magic there. But when we start getting into fiber and we start getting into custom loss values, that starts to be tricky. And I don't necessarily have confidence that the person in the field is going to know how to set up those custom limits exactly the way I want them done. Another thing that can be really helpful is the cable IDs. You can preload the cable IDs. You probably have them on an Excel form, and you can send those cable IDs up to the cloud right away. That'll save you time from after the fact having to go back and edit all those cable IDs. So the project manager will do the configuration, and he will send this up to Linkware Live. It's a cloud-based service. It's not a server sitting underneath our desk. It's actually Amazon Web Services that are driving this. Now, once the test configuration has been set up, the technician is going to connect his tester to the internet. How do you do that? You can either use a little USB Wi-Fi dongle, connect perhaps to your hotel's wireless network if you're traveling, to the customer's wireless network if they have one. If they don't have a wireless network set up at the job site, configure a hotspot on your smartphone, and you will be able to connect to the internet. And then you say, hey, give me the new configuration. This is nice because a person can switch job sites in one day. In the morning, they're working at a data center. In the afternoon, oh, the bank called and they really want you to go over there. Well, before you go over to the bank, download the configuration and you know what test limits you're going to be looking for at the bank. So the technicians download the test configuration, the cable IDs, and they go and run the tests. And I've been saying at the end of the day, before you have the first beer, that delicious, cold, frosty beer that's calling to you, stop for a minute before you do it. Connect the tester and send those test results back up to the cloud. Now, one of the biggest challenges we're finding about Linkware Live is connecting to the wireless access point. It has all the difficulty of connecting your phone to a wireless access point. Maybe there's an SSID. Maybe there's a password for the SSID. Maybe there's a password to get into the wireless network. You can do it. You can get past that. It may take you a couple of button pushes to get connected, though. So one trick that I've found, if your tester is connected to Linkware Live and you've downloaded the test result and you've run some tests, before you turn the tester off, you can even unplug the wireless card or unplug from the wall port the cabled connection to the internet that you have. Before you turn the tester off, sync the tester again. Send those test results back up there. It's fast. It's pretty simple. Now, if we've done a good job in getting those test results up there, then anyone can look at the test results. The project manager can see how much progress did they make. Did they use the right cable IDs? A consultant who's concerned about the progress of the project can see how we've been doing, especially if we've got thousands of tests to run. We want to start looking at those test results as soon as possible. We don't want to wait until 3 days or 2 weeks into the testing to go, wait, you're using the wrong limits. That's not going to be any fun. And of course, if we accidentally, shall I say, delete the test results on the tester, they're already stored up there in the cloud. All right, what have we talked about today? Inspection equipment. It's not just cleaning. Please don't just take the dust cap or the end protector off of your patch cords and start cleaning right away. Inspect them. Make sure they're clean, especially with the MPO connectors. You got 12 options to go wrong there. And it's just such a state of confusion. Is the cord dirty? Is something going wrong with the tester? No, you really want to make sure that you have inspection equipment, and if you're doing multi-mode, you'll need the UPC tips, and if you're doing single mode, you're going to need a second tip. You're going to need that APC tip. Get enough time set up to set your reference. We saw that if we're setting a reference to run a trunk cable through a regular OLTS with just one output and one input port, it's going to take us some time to get that reference set up, but we really want the reference to get set properly. If we don't set the reference properly, if we don't follow those 15 steps that we walked through, you're going to get to a situation where you're going to have a gainer. And customers should not accept gainers in a loss test. Something has been done wrong in the process there. So make sure you've got a good reference set up. Make sure your test reference cords are in good condition. Make sure they've got reference grade connectors on them. Make sure they are encircled flux compliant. That's going to help with those tight limits. Now, speaking of the tight limits, know what your application is. We talked about the 10 gig limits being 2.5 dB. If you're running 40 gig, the limits are even tighter. 1.9 dB is your loss limit, and your distances get greatly reduced. OM3 is going to support 40 and 100 gig only out to 100 meters. This is where the additional modal bandwidth that you get in OM4 and OM5 can be practical because you're going to get an extra 50 meters. You can run 40 and 100 gig out to 150 meters with the OM4 cable. Yes, I know you've got a super cable and it goes extra far. You've got a super GBIC that goes a little bit farther. That's fine, but what the standard's talking about is 150. Testing OM5, here's the good news. Testing OM5 is the same as OM3. Actually, the limits are the same as OM4. We've got a loss value. We compare that loss value to the application. And the distance limit on OM5, for right now, I'm going to stick with 150 meters. The modal bandwidth of OM5 is the same as OM4. So OM5 isn't giving us any extra distance. What OM5 is giving us is the possibility to work at 4 different wavelengths, 4 different windows, if you will. I like calling them 4 different colors, a color we can't quite describe. And each one of those colors can transmit today 10 gig. So a single OM5 fiber could transmit today with the right transceivers 40 gig and receive 40 gig on the other fiber. Down the road, probably do more. If you have a lot of MPO trunk cables to test, boy, a dedicated MPO port on your tester sure is going to be faster. Again, you have a container load of MPO trunk cables to test before you put them in the data center. A multi-fiber is just going to be worth your time to be running those tests faster. You have 1, you have 2 MPO trunk cables to test. Sure, use your OLTS. The cost difference may not justify that. Finally, we want to be using Linkware Live for better results management. Let's use Linkware Live to get the right configuration into the tester and the right cable IDs into the tester. And let's use that cloud service to make sure that everyone can see the test results that we're sending up there. Well, coming up on the end of our time here, I don't want to take up more of your day. I appreciate everyone sitting in and listening through this. Let me check real quick and see if there are any questions that are out there. Through the chat window, please go ahead and type in a question there. Here's a fun question. I'm using OM3 test reference cords. Can I test OM4 cable? Yeah, if your test reference cords are OM3, go ahead and use them on OM3, on OM4, even OM5. The one thing you want to be careful about with your test reference cords is you don't want to use test reference cords that are made of bend-in-sensitive fiber, because if we wrap them around the mandrel as we did before to get rid of the higher order modes, but we're using bend-in-sensitive fiber, guess what? It's not going to work, and you're going to end up with test reference cords with, well, with a reference value that's too hot, and it's going to give you some pessimistic readings. Okay. Well, looks like that's going to do it for our time today. Appreciate very much everyone's participation. Look forward to speaking with you again in the future. Again, my name is Jim Davis, Jim Davis at FlukeNetworks.com. Thank you very much for your time and attention. Have a good day.